Good evening, everybody, and thank you for joining us here tonight. My name is Julie Willis, and I'm the Dean of the Faculty of Architecture, Building and Planning here at the University of Melbourne. I'd like to begin by acknowledging the traditional owners of the unceded land on which we meet, the Wurundjeri Woiwurrung and Boonwurrung peoples of the Kulin Nation. We pay respect to their elders past and present and recognise the deep knowledge, cultural practice and custodianship of country that continues to shape and sustain our communities today. It's my very great pleasure to welcome you to this evening's Tresidder lecture, Urban Wild Ecology. Mio Tsuneyama is the 2025 Robert Garland Tresidder Fellow at the Faculty of Architecture, Building and Planning. This fellowship enables artists, business innovators, designers, policy leaders, startups, architects and scholars dedicated to the development and promotion of design-based innovation to visit Melbourne. And we're grateful for the very generous ongoing support of the Robert Garland Tresidder Fellowship. And I wanted to acknowledge that Bob Tresidder is in the audience tonight and to thank him very much for being here tonight. Thank you, Bob. So we're greatly honoured to welcome Mio Tsuneyama and Fuminori Nousaku, two internationally recognised architects whose collaborative work reshapes the way we understand urban and ecological systems. Mio Tsuneyama is a Japanese architect and educator and the founder of Studio MNM in Tokyo. She studied architecture at the Tokyo University of Science before completing her graduate degree at EPFL in Lausanne. Her academic career includes teaching at Tokyo University of Science, a visiting professorship at EPFL, and currently a role as Adjunct Associate Professor at Columbia University's Graduate School of Architecture, Planning and Preservation. Her project, House for 7 People, received a special mention at the Venice Architecture Biennale, and her ongoing work, including Holes in the House, exemplifies her deep engagement with sustainability, urban resource cycles and reconnecting architecture with ecological processes. Fuminori Nousaku completed his doctorate at the Tokyo Institute of Technology before founding Fuminori Nousaku Architects in 2010. He's held academic roles at Tokyo Tech, Tokyo Denki University and is now Associate Professor at Tokyo Metropolitan University, as well as being an Adjunct Associate Professor at Columbia's GSAP. His award-winning practice spans architecture, installations and ecological research. Together, Tsuneyama and Nousaku's work challenge us to see cities not as separate from ecology, but as embedded within it, proposing architecture as a form of urban wildness, attuned to cycles of growth, decay and renewal. Please join me in welcoming tonight's speakers, Mio Tsuneyama and Fuminori Nousaku.
Thank you, Julie, for the introduction. I'm Mio Tsuneyama from Studio MNM.
I'm Fuminori Nousaku.
So we talk about urban wild ecology today. After World War II, population growth led to massive global urbanizations. A side effect of this has been the ubiquity of the lifestyle defined by mass production, consumption, and disposal. Tokyo is no exception to this phenomenon and is known for its accelerated development. It's now started to deteriorate. Since 2004, Japan's population has started to decline, creating an increase in the number of vacant houses throughout the city. The culture of scrap and build cannot be sustainable, thereby necessitating a change. Japan has now been moving towards the use of existing building stock in its architecture. The Tohoku earthquake and the Fukushima nuclear plant accident in March 2011 had a great impact on Japanese society. Until then, we didn't know that Tokyo electric power was delivered from Fukushima. And we noticed that we lived in a world where we didn't know where the things around us come from. Building in the heart of Tokyo function as tool of economic growth. Therefore, it is essential that office buildings, tower condominiums, and other commercial facilities are in a constant state of redevelopment in order to maintain a new and clean image. On the other hand, the perimeter of the city is a residential area with detached individual houses and small apartments. Due to Japan's declining population and increasing elderly demographic, this area is becoming depopulated and seems to be decaying. In expired city, waste is converted into resources and used to make small updates. The process of recycling begins, for example, from unoccupied buildings, old shops front, or neglecting gardens. Our architectural approach begins with the resourcefulness. We aim to create livable spaces using what was once considered waste, decaying vacant houses, solar energies, and soil microorganisms. It's like how fungi grows on expired food as nutrition. So holding the house is a home and studio we live. The original 4-story steel structure was 30 years old when we bought it. We moved in after making holes, which is red, in each floor and dismantle interiors and are innovating in it stepwisely while living in. The house located in Nishioi, where it only takes 5 minutes to the center by train, has not been redeveloped due to the complex topography on the edge of the plateau. Shinkansen, the fast train, and the local trains that cross the area generate loud noises. The area is mainly residential, but since it's Nikon's hometown, small factories used to be settled which now tend to be reconstructed into housings without lack of green spaces. So our house is this yellow one. And so therefore, Nishioi is the cheapest land in Shinagawa Ward, this area in Tokyo. And we bought this yellow fancy house, which was 30 years old, and we removed the shutters, which used to be paper storage. And second, third, fourth floor was for the house for 3 generations for 6 people. And then we took away the shutters and we lived for 1 year without windows. So hot air and the cold air was coming up, also cockroaches and mosquitoes. We suffered a lot. So when we installed the windows on the ground floor, we appreciated a lot. So the holes is also, of course, like connecting each floor as a one room, but also like it's bringing the light and generate the sound is connected, and of course the air is circulates. So it's kind of device to control the environment. So when we moved in, the cable was hanging from the ceiling, and the part of the floor was missing. Nails are sticking out around the holes. Also, rock wool was exposed, and when we opened the windows, it was falling down. And there was no window on the ground floor, which we wanted to renovate to our office. So to get to our comfort, we started to paint the rock wool to coat it, and also like started to insulate the house. It used to be no insulation. So this is, of course, for our comfort, but also like aim to reduce the load of the planet. And the advantage of living in the house and renovating at the same time is we could feel where the uncomfort is. So this bay window was carrying the cold air. So we insulated with the polycarbonate panel, and also we checked with the thermography. So when we open, you see that it's cold outside. It's still like the window is there. And we also started to connect the energy around us, so the solar heat and wood pellet stove. And this reconnection also made us to rethink that modern kitchen was depending on the infrastructure. And so we started to bake the cookies on the rooftop with solar collectors, with double glazed vacuumed tube, and also like pellet stove on the ground floor in the office to make a stew. So like suddenly, if we reconnect the energy around us, the cooking was jumped out from the kitchen. Urban waste is every day is created in the city, and also like the materials in the museum after 2 months of the exhibition of one-to-one model, we collected from the waste depot and we cluttered in the office. So we didn't expect that direction of the design, but the office became very woody. So like our attitude is kind of hitting back like what we found in the city to the design. And by time we started to also recognize the importance of soil environment. So we decided to break the concrete of our small parking lot and regenerate the soil with organic matters. So unfortunately, it was a very good concrete. So it took 2 months and a half, like 2 hours every day. We broke the concrete with the stuff, and it also that generates the concrete bubbles, which we drove to the intermediate waste depot. And I witnessed to the mountain of the concrete and asphalt, which it's really a long time to take to go back to the soil. So this experience made us to think that, that we have to reduce how much to use the concrete in our project as well. And we started to dig the ground because it was covered for 30 years to penetrate the rainwater slowly to the ground, which brings the oxygen into the soil, and bamboo charcoal and the humus to reactivate the microorganisms, and plant nursery tree, and got some earthworm from friends, and bring back the food waste directly to the soil every day. And only 2 months later, it was full of life already. And also bringing back the myceliums into the soil. This is a sign that soil environment getting healthy. And 1 year later, it's not a beautiful garden, but full of life. Instead of 2D concrete surface, it suddenly became 3D. And this is like a potato plants invading the weed. So once we have this soil surface, even very small, like 3 square meter, we got the food cycle. We bring back the food waste every day. And next year, the tomato grew up. And on rooftop, we started to grow the carrot and dry the vegetables to conserve. And now, 2025, it's jungle. We have to cut like every season to not disturb the neighbor too much. So through this experience, like we also like started to think like on urban scale that if we have a small spot of the urban soil, even like in concrete jungle in Tokyo, it creates also the continuation of the shadow. which reduce also like heat island effect with the population of the the plants, and also recreating the soil underneath of underground water channels. And then like why we also have to cover all the streets with asphalt is the question. So if the street is less car, we can also bring back to the soil. So this is our imagination of to convince our neighbors to bring back our street to the soil. So through this experience, we started to also understand like which materials goes back to soil easily and not. So also the insulation for at the beginning we used like a styrofoam from the petrol-based materials, but now the upper floors we insulated with wood fiber, and also like ceiling is covered cladded with the cotton, which is thin and easy to go back to soil, and the balustrade as well. So this is like a bedroom after 2021. And this is comparison from the beginning and to 2017 to 2021. And now we have a balustrade and a net because of the kid was born 2021. So house is kind of also adapting like our life stage. In 2024, in January, we have an exhibition in Toto, which is like only one of the most important architectural gallery in Japan. And we designed contents to not waste anything, because the exhibition was held only 3 months. So this is kind of material cycle of the exhibition. Like all the exhibit was like meant to be located somewhere in the village, for example, in Kamanuma village where we have a project, or our house. So the exhibit was kind of framed or like designed to be fitted into our house. So this is, for example, toilet with also like the base of the cladding, and after the exhibition we installed with this indigo stained panel. This is the most, I think, beautiful space in our house. So also like the screen, like the shoji paper screen was also exhibited and we installed later, and the mycelium lamp as well. And also recently, this summer, we this pergola with the solar panels and small shed, was exhibited in the courtyard of the exhibition, and we relocated this shed to Kamanuma village where we have a project. Also, in our rooftop, we relocated this pergola with the solar panels, with traditional construction method. You see it on the top. This is not legally accepted, but for now, like so far, nobody claimed. So now we have a battery, and it's not connected to our electrical system of the house, but we have a battery, and we could plug in directly. So all the phone was charged with the solar energy, and of course, like our TV is our Apple. So when there is no sun, we can't see the TV. So this is kind of a result of our small project, which is bubbles. And this small project, like assemblage of these small bubbles, is shaped our project or architecture. And our renovation is still going on after 8 years or 7.5 years. We take the coincidence resources such as people, energy, and the waste which we can find around us into the design. The phenomenon of top-down enforcement of policy and institution to address environment issue refers as political ecology. And on the other hand, urban wild ecology adopts a bricolage approach making the best of available resources is a practice rooted in our living spaces, rather than in wildness or Orientalism. Urban wild ecology focuses on the disconnected part of rather than the transcendent whole in like deep ecology. It acknowledges that depth is found in localized elements rather than in a framework that encompasses the entire planet. We will approach architecture through a series of small-scale realizations. So urban wild ecology was originally subtitle of Holes in the House Where We Live and Innovate. But by time, if we analyze this, comparing with like to both extreme and political ecology and deep ecology, it's more like a human and non-human entanglement. And this is a diagram which is, you might know, like it's showing the biosphere, natural cycle, and the technosphere, technical cycles. And it's known that it took kind of not pollute each other. It's meant to be good that it not mix this cycle. And this is a butterfly diagram. The first cycle is a biocycle, and the blue is the technocycle. But recently, the third cycle is kind of introduced, which is regenerative design. This is among recreation of the nature. It's like a human controlling the climate, or like a modification of DNA. So this is meant to be for human, but we got to know that recently that this polluted both cycle. So our attitude of urban wild ecology is more, we propose like full cycle with weak interaction, like a fungus or fungi to eat the nutrition as urban resources, to assist both cycle, like biocycle and the technological cycle. And this is a reference of Minka and the Satoyama ecology. Satoyama is kind of village managed woodland between village and the mountain, where we get the resources. The Minka is like folklore house, which we call it also vernacular house. And this house and the site is a like smaller circulation of the local circulation of the materials, which create also the ecology. So like, for example, thatched roof is like thatched with the thatched field plant, which is managed by the villagers, and it's kind of commons. And it's bring back the manure and the waste and treated by the villages. So the Minka is kind of the folklore house. It's sustained with this ecology. And what we kind of try to do is finding resources around in the city, which is slightly different from the Minka. So one of the resource in Tokyo or in Japan is urban waste, which is abandoned house. So after World War II, probably switch. So in Tokyo, the abandoned house is generated because to sustain the housing industry, scrap and build. And these vacant houses, recently the young people started to live in the house shared as a, shared communal housing. And this is a kind of new typology for the living. So house for 7 people is one of the shared house, which is renovated from the individual house, located in the center of Tokyo. And this is kind of the difference between individual house and the shared house is the common space where the residents will meet. So defining the common space is very important. And during the renovation, we found that when we demolished the house, the part we don't need, we found this steel door. So we decided to define this living space with the storage like which this building used to be. And this is like when we open the sliding door, it's connected to the front street, and the curtain can adjust to control the privacy between the residents, and they can also use the big use, like having the party as well. So this is where I build a model, renting this living room, and sometimes they have a yoga lesson together. And the second floor used to be a living, and they had a timber structure. And to reinforce the timber structure, the partitions are installed as a backbone to create also 5 rooms for the people unrelated. And using the shape of the roof, they have a loft space. Even the room is small. And because of this backbone in center, it creates like Engawa-like corridor, which we could keep the windows, which used to be bathroom, toilet, kitchen, so that the inhabitants can feel that this house history. And balcony was unused and covered with the tent and meant to be like a secondary living room, but now it's used for the laundry drying room.
So I explained the next theme, material flow. So this is a case of Kitayama cedar of Kyoto. So cedar logs of Kitayama are used for the columns and beams in Kyoto. Craftsmen will polish the log before cutting this Kitayama cedar. It's necessary to do pruning. This Kitayama cedar is planted from the mother tree. So in this way, various people and things are involved in the network of production of building materials. So each architecture element is connected to products. There is processing, there are raw materials eventually reaching nature. So in this industrial society, consumers can choose only products, cannot choose the upstream of the network. It has become a black box. So it's important to reconsider about the quality of the network by finding alternative options. So that building is made of various materials, and building is at the node of the network of each materials. So architecture elements is connected to natural resources. So architectural network is a complex mesh. So we need to rethink not only our materials, but also our waste network. So this project is located in Takaoka City, Toyama Prefecture. Takaoka is situated in Japanese seaside countryside. Due to Japanese decline in population, there's an increase in vacant houses in rural areas. In this project, we aim to repurpose existing materials and reduce the size of the old house. So this shows the construction process. In the first phase, we added the kitchen and bathroom to the grandmother's residence. In the second phase, we removed the roof tiles, storing them on site, and relocated the roof structure using a crane. The 2-story building was dismantled. In the third phase, new foundations and walls were constructed. The roof was placed on the new structure. Finally, the roof was covered with the existing tiles. So this is the construction movie. So this area features a typical tiled roof landscape seen in rural residential areas of Japan. So 3 generations of the family once lived here, but now only my grandmother are living. So the building was renovated while preserving various architecture elements and materials that held family memories. Due to a leaking roof, so we reused the shoji paper sliding door, and this is a doma, and we use many materials. So this is the second phase to relocate the roof. So cutting the top of the columns, and the roof lifted with a crane. The roof structure was stored in the garden, and we measured the size of the roof, and then we created the new basement. So this is a new structure of the dining room. So this is a view of the 3 buildings. So this is the dining room. So paper sliding door and wood carving were reused for grandmother's residence. So this house is harmonized with the continuous landscape of tiled roof. So next theme is foundation. Through the practice at holes in the house, we learned the importance of the subsoil environments. Soil is the basis of life. However, it has been regarded as a nuisance to architecture and cities. We began to seek architecture that coexists with soil. So,
So this shows the mother tree provide the nutrition to nursery tree, which there is no sun like directly get. And this mycelium is helping this, like sending the nutrition and also information to the nursery tree.
So traditional living environments consist of houses with independent foundation and dry stone masonry retaining walls, allowing rainwater to percolate in the soil and coexist with the subsoil environment. But today, most urban spaces are covered with concrete and asphalt, and rainwater is drained into communal ditches. microorganisms are acidified and the soil is in an unhealthy state. For example, looking at the foundation of wooden houses, the stone foundations was replaced by a concrete continuous footing and then by a solid slab foundation with improved moisture proofing and earthquake resistance. Carbonized pine piles are under the stone foundation to prevent subsidence. In healthy soil that is permeable to fresh air and water, mycelia enter the porous surface of the piles. The mycelia bind the soil to the piles. So in the Akeno raised floor house, we adopted an independent foundation to minimize disturbance to the mycelium and water veins in the soil. Akeno, this house is situated in Yamanashi with Mount Fuji to the south. The independent foundation is used to allow water and air to circulate through the soil. Instead of concrete, we propose a foundation made of recyclable steel plates. A high floor will keep the foundation dry. Even if there is termite damage, it can be inspected immediately. The choice of building materials will also vary to return to the soil. In addition to building material made from wood, natural stone, earthen walls, mycelium, straw, and hemp, we focused on straw bale construction. This straw bale house construction methods originated in the United States in 19th century. In areas where trees did not grow, people built their houses with the byproducts of grain. So we use wheat straw as well, insulation materials. So we carry the straw blocks, tie ropes to the stripes, piles up straw blocks, push them into place at the top of the pile. So secure ropes with tied to bamboo and apply the soil by hand. So this is the detailed section. The wooden structure is placed on an independent foundation. The roof slopes down to the south to maximize the sun's energy. The insulation is made of organic materials such as straw and wood fiber. So this is the south elevation. So that 2-meter deep veranda overhangs the houses. The steel plate foundation opens up the ground surface, allowing air and water to penetrate into the soil, weeds are growing around the foundation. So this is the living dining room. The windows are very thick with straw bale walls. The shoji screens are traditional Japanese architecture elements are biodegradable materials. So next project is a piles and a pointed roof. The idea was to allow the same as Akeno, but it's in the city situation, urban situation. The eastern part of Tokyo are lowlands. The western part is plateau. Commercial areas like shopping streets are often located in valleys where water collects and the ground is weaker. So this is a section of Kanto loam layer. The base beam timbers are supported by 8 15-meter steel pipe piles. They have a screw at the end, which can be reversed to allow them to put out during demolition in the future. So we returned all the ground on the site to the soil. A trench is dug where rain falls from the roof. This is a section detail of the mechanism of the water penetration. By placing dried leaves, branches, bamboo, charcoal, and stones in the trenches, rainwater can easily permeate into the ground. Because of the high density of the cities, small soil surface accumulation can play a major role in improving urban soils. So next is Satoyama Commons. So we are organizing a Satoyama School of Design in the Kamanuma village of Chiba Prefecture. In collaboration with 4 university laboratories, we engage the conservation of the rice fields, learning about the Satoyama ecosystem. So the characteristic of SSD includes thing-oriented design and collaborative construction. So this is a tiny house that was built together with our students. We designed and built under the guidance of traditional carpentry master. So we focus on stone foundation, not use concrete. Students bound pine stakes, placed the piles in the soil, filled them with gravel and set stone foundation. And the students marked the wood with ink, cut the joints by hand, and carved the holes with a machine. So this is the wooden frame assembling. We tie wooden frame and the bamboo lattice together with ropes using square knots and carpenter's binding knots. So we thatch roof using rice straw. The straw bundles are connected into the sheets to create straw mats. So these thatch mats ties and secure with straw rope to the bamboo lattice. So this tiny house has a floor area of 4.5 tatami mats. Ladder from under the floor allows access to the interior space. So we call this approach practical ethnography of architecture. Ethnography is documented through oral history and interviews, but in architecture case, knowledge is embedded through building process techniques and tools. So this is to contrast design strategy, quantification, and scalability in space-oriented design are developing with capitalistic society. But in contrast, things-oriented design is one of the approaches that counteract this trend.
In modern times, the use of the concrete and the plastic has become common, allowing for easy shaping and design. However, when using biodegradable materials, it's necessary to carefully consider how to protect the building from rain and humidity. This was a common practice in construction from earlier times. Modern architecture needs to learn from traditional ecological knowledge. In the past, the wooden houses were built by local carpenters and community members. Throughout the 20th centuries, regulation and industrialization transformed wooden houses. After the great earthquakes, the building standard laws were revised, strengthened house structures. Mass production of houses increased to accommodate post-war population growth during the period of rapid economical growth. Home builder emerged and the strict fire protection regulation were introduced due to urban densification. Though wooden houses have developed into their current form through a complex process of industrialization. There are two main types of construction method for wooden houses in Japan: the traditional construction method on the left and conventional construction method. Conventional construction methods are based on carpentry techniques that has been defined through industrialization to enable mass production. The method uses small section lumber, machine-dried lumber, and joinery hardware. They typically do not last longer and are rebuilt after one generation. On the other hand, traditional construction methods are handcrafted by carpenters without the use of hardware. They use a large section of members and the naturally dried lumber, and they are built to last 100 years and more. House on classical element is an off-grid house that uses traditional Japanese construction method, requires less energy, has a long life, and uses materials that return to soil. To maintain a healthy subsoil environment and coexist with the slope, the house will have a raised floor. The raised floor will allow for the ventilation underneath of the floor and keep the floor beams dry. An independent foundation can reduce the amount of concrete used for around 60% compared to typical concrete mud foundation. And the covered terraces are placed on opposite corners to allow the natural ventilation. And planning with normal wood spans allows the structure to be constructed on solid wood rather than glued imported laminated timber. In traditional construction methods, the upper and the lower wooden beams are jointed together in this way, so interlocked. No hardware is used that could damage the wood during the earthquake, so it will last longer. Timber is supplied directly from two forestry cooperatives in the Kanto region. Wood is cut using specialized portable sawmill. Carpenters can process the wood themselves without going through a sawmill, which directly benefits the forestry cooperative and allows them to freely cut thicker materials suitable for the traditional construction method that are not specified in the standard. The left side shows machine-dried wood, while the right side shows natural drying wood. Machine-dried wood has many internal cracks, you can see, as the rapid drying process damages the wood cells. Naturally dried wood requires about a year to dry, but it contains to lose moisture and gain strength even after the building is completed. In traditional construction methods, naturally dried wood is used because the joint involved significant materials removal. So this is the shape of the foundation to minimize the use of the concrete, which is 45 degrees. And recent highly insulated and airtight house use many chemical products in the plastic sheets, such as the vinyl and the plastic, which do not absorb the moisture. This house is constructed with cedar wood, cellulose fiber made from recycling paper, and other materials that absorb the moisture, and it can breathe, and this keeps the wood structure last longer. So cedar board and the plaster are used for the walls. No glue plywood is used. The wall absorbs the moisture when it is humid and release the moisture when it's dry. This is breathing wall. So in a normal energy efficient house, which is in the middle, energy consumption during the operation can be reduced, but a lot of CO2 emission is used during the production and the disposal. Therefore, we can reduce energy consumption during the production and the disposal while realizing energy saving during the operation. This is the south elevation. The wooden box appears to be floating on the independent foundation. And this is the west elevation. You can see the two Tesla battery because the roof is materials is covered with solar PV panels. And this is the wood joint interlocks from the interior space, which is sticking out, so never fall down. And the living room is, the wood stove is designed with high temperatures, allows it to burn wood scrap and well. And the study and the second room. And this is the slope you can see and looking back to the Mount Fuji. And this detail section shows that our architecture is treating at the same time the construction method, but also the lifestyle, energy, and the soil environment at the same level. And the buildings are made of networks and the various materials from raw materials to disposal. And human skills and the knowledge are its important actors, as well as the work of microorganisms in the soil. This network forms a mesh with building as a temporary node. We view the architecture as this complex mesh, just like a mushroom with its head above the ground has a spread network of mycelium, its main body. However, industrialization has a black box, the network of materials. Architects can open up the black boxes, break down the barriers and the institutions of conventions, unravel the grid of the forced alignment, and thereby reconnect the network into an ecosystem. This creates habitats of multi-species where human and non-human entangle. So this is the last slide. So architecture has been conceived within the paradigm of the space, but we have been exploring the possibility of thinking within the different paradigm of relations between things. What is this depicted in the drawing is a way of intervening in the relation of things. So the sizzle on the right up means cutting a network. It indicates a forceful cutting of complex network. Grid means that the network is fixed and planned. It indicates the control of the mesh that expands exhaustively and can be squeezed into the system. The canalization means to collect and accelerate the network. It indicates the development efficiently and the concentration of the distribution through the industrialization and of the capitalist system. Barrier is a wall that stands in the way of the interconnection legal system, and the social systems becomes a barrier, creating barriers between resources and the people. The hammer shows the action of breaking down the barriers. It's like our hand. The hand is reconnecting the networks. It finds the broken meshes and reconnects them. This reconnection of the relationship between things is the practice of the architect. Thank you.
Thank you, Mio and Fuminori, for a fascinating and thought-provoking lecture. Really quite extraordinary to see your thinking processes and the way that you have embedded that into your architecture and design that allows for all of these things to occur. Truly wonderful. Thank you all for being here tonight. Before we close, I'd like to just highlight two upcoming exhibitions. From September 4 to 7, we're delighted to be collaborating with the Robin Boyd Foundation to present Koya Shed Architecture at Walsh Street in South Yarra. Curated by Nancy G, Mio Tsuneyama and Fuminori Nousaku, it explores the humble koya or shed as a modest but powerful architectural form that questions scale, permanence and construction. And from the 23rd of September, the Parts of Practice exhibition will be on display in our design gallery here in the Glyn Davis building. This exhibition brings together emerging Australian architectural practices, focusing on the fragments, processes and experiments that together make up contemporary architectural practice. I warmly encourage you to come and visit these exhibitions, and you can find out more details on the MSD website. Thank you again for joining us, and I wish you all a very good evening.